just so that all of us are on the same ground. So I just want to remind you that we should, if you did forget that, or if you don't remember properly, or if you have some part of the memory that you are missing about what happened in the circular motion class, I'll do a small, very fast 5-minute review of all the formula, so that as we dive into the maths, you're not altogether lost. Just for my convenience, so that I am stopped less often. So আমাদের ক্লাস নোটস গুলো আছে এই জায়গায়। First thing first, these are the 3 questions that are very important for us. V equals to omega r, and centripetal force is given by m alpha, or m v square by r, or m omega square r, where centripetal acceleration is given by v square by r, or omega square r. The one of the basic equation is that যেটা এখানে বক্স করা নাই, which was taken for as a default, which is theta equals to omega t, which is angle equals to angular speed into time, or you can write that angular speed equals to angular displacement, which is some sort of angle, radian, divided by time, which actually comes from this expression s equals to r theta. ওই দুটোকে কম্বাইন করলে আমাদের এটা আসবে। এখানে আছে হচ্ছে in this case this should have also instead a box, omega equals to theta by t, এখান থেকে আমরা 2 pi by capital T অথবা 2 pi f pi, which essentially is what is the expression in terms of the time period / frequency. Then we have 2 different force situation managed for horizontal or a conical pendulum, and then we had a certain thing for object moving in vertical circle. So we had some discussions over here. We went through them. These are theoretical discussions. And then we have a little bit of question about banking. এখানে আমাদের ব্যাংকিং এর পার্টগুলো দেখানো আছে, যে একটা অবজেক্ট স্মুথলি টার্ন করতে হলে তাকে কতটুকু টিল্ট করলে সে স্মুথলি টার্ন করতে পারবে। কারণ হচ্ছে whenever an object is going to take a turn, it has to have required amount of centripetal force available to it. Now the more it can lean to the left, the bigger component of weight is going to start pushing him to the inside of the curve. This is exactly why in the MotoGP racers you'll see that whenever they are taking a turn, they're almost lying down on the track. I mean, they're literally lying down on the track. All the point is that the farther they can lean, the more centripetal force they can get from the component of their weight, and faster they can go around the turning. That's pretty much the aim of any race. That's why they do that. If you wonder if is that dangerous, if you can maintain a very perfect what can I say, sweet equilibrium between your centripetal force and your weight distribution and the speed, then it is not at all equilibrium. I mean, a MotoGP driver who is making good driving with high speed and cutting sharp corners is nothing less, in my opinion, compared to a good opera or a great symphony. I mean, it looks so good to me. So that's another thing. And the tires are also made in such a way that even when you lean to a very high angle, your tires are gonna still maintain contact with the track, so that you do not altogether lose track from the tire. So those tires are pretty round, and they're that much big enough that you would get good contact with the ground even when you are quite tilted. So that is the basic idea of banking. এখানে ব্যাংকিং এর কিছু ইকুয়েশন দেওয়া আছে, এটা লাগলে আমাদের 11 কেসে আসলে আমরা আবার ডিটেইলসে আলাপ করব। Then comes the idea of gravitation. Gravitational basic formula হচ্ছে এটা, you know these stuffs. And then comes the idea of gravitational field strength. Gravitational field strength এর basic expression হচ্ছে এটা, G equals to gm by r square. And then comes the idea of gravitational potential, which is different from gravitational field strength. Field strength is force per mass, and potential is work done per mass, so which is given by 5 m joule by kg. Here we have a little bit of integration and mathematical lunacy to derive to this formation. So we have phi equals to minus gm by r. This is the generic expression for this thing. In all the cases, you have to remember that these distances that we are showing, they all mean distances from center to center. Very, very, very important. এই একটা জিনিসের জন্য দেখা যাবে যে তোমার ওয়ার্কশিটে যে নাম্বারগুলো দিছো, all the numbers that you shared for problem solving, we might as well come across that much of the problems that you couldn't make answer because you consider this as the radius, or maybe you consider this the distance from the surface of the radius upwards. Maybe you did not consider the distance from the center to center. That's one of the very common ground for mistakes of mathematics in the gravitational chapter. So we'll see about that in a bit. Then we have these graphs. We know how these graphs work. For most part, I didn't explain you this part because I cannot do it very well and not covered in your syllabus. But apart from that, you have some idea about how these graphs work. And then we have this expression that for GP calculation or for delta GP calculation, change in gravitational potential energy calculation, we cannot use MGH MGH erratic in all cases as a rule of thumb, because now we are gonna move objects in celestial scale, so we cannot assume that the value of G is constant from position 1 to position 2, because we are gonna move them so far apart. So G values, small G in this case means gravitational field strength, for those 2 points would be different, so we cannot directly ram that formula MGH. We have to consider the idea of gravitational field potential change, and we have calculate delta GP into mu delta phi, which gives us this expression through all the replacement. You know how this works. However, in applicable cases, in certain applicable cases where h is really small compared to the distance where the particle is located, in those cases we can practically apply GP equals to MGH. So এরকমই কিছু question আমাদের আছে worksheet, and they will also ask you that why using this equation in this case is valid, and you have to be able to write a good well constructed answer to get good marks in those questions. As long as you can get the concept right, it's not very difficult. Acha, then we have the idea of the escape velocity. Escape velocity is that what is the minimum speed with which if with an object, you know how the definition is. It is given by this expression root over of 2gm by capital R. Once again, this capital R is the radius, the radius in this case means that we are going to shoot this particle from the surface of the planet. So this R also means the distance from the center of the particle of the object to the center of the planet. So R always R, the default R in all the equations, whether you shoot it in smaller or capital R, they are always meaning the distance from center to center. Very important for you to remember, center to center. If you wonder, because the reason is very simple. Whenever we are applying the law of gravitational things, we assume all the objects as particle. Now, considering them all as particle means that all of their mass is considered to be concentrated at their COG. All of their mass is considered to be concentrated at their COG. This is why the idea of center to center is so much important. So shouldn't mess this up. Beyond that, we have the idea of satellite. Satellite ekhane amader orbiting equation আমরা বের করছি. We got this from using the logic Fc equals to Fg. Centripetal force, required centripetal force will be supplied from the gravitational force, and by equating all the sides on relevant parts, we eventually came to this expression. R cube is proportional to T squared, which is basically called the Kepler's law. It's a pretty important thing. We'll use this proportionality much too often in the worksheet as well. And then over here, using those same sort of equation, but by going for a different replacement method, we also calculate what would be the linear speed of a satellite in an orbit. We happen to find this root over of gm by r. So two of these speeds shouldn't be confused by. One is the escape velocity, which is root over of 2 gm by r. Here we have a 2. Take a good look. Whereas in the case of the orbiting speed or linear orbiting speed of the satellite is given by root over of gm by r. So these are two different expressions. They'll be helpful. Then we have the geostationary satellites. The idea of the geostationary satellite is important. Polar satellite same. The basic thing is that geostationary satellites have a period of 24 hours. They have equatorial orbits. And the third point, if it ever comes, that they are always observed in the same position in the sky for every time, or they are always in the same position in the sky for a certain location on the Earth. So if you can detect a geostationary satellite for your position, that will never change its position. It will appear to be stuck in the sky by some glue or something, because it is stationary with respect to the Earth's surface. Then we have the polar satellite. You know what that is. Then we have the two graphs or combined objects. So because gravitational field strength is a vector quantity, so for analysis of gravitational field strength, if we have to consider them as vectors. That's why the individual graphs exist on opposite sides. So the combined graphs has a x-axis intercept, whereas for the gravitational potential, the entire component is negative. So we'll just have to put them down, and we have the common factor. Now, one of the things that I would like to tell you is that these 2 points for 2 objects, these points, let's say, the part that I'm telling you right now, I didn't tell you earlier, I just remembered to tell you this right now, is that the amount of distance, the location between the 2 planets, or let's say we name them planets, the location between the 2 planets where the null point is located, which is the point where the resultant force is 0 or gravitational field strength is 0, that is not essentially the same point where the potential is minimum. It does not always work that way. There is a certain mathematics which popped up in one of these years. Maybe we'll come across this math in our worksheet. If we don't, then I'll definitely, if it's not included in our worksheet, I'll pick it up from the source and I'll show you that this thing and this location, they are not essentially at the same point. এটা কেন সেটা ম্যাথমেটিক্যালি প্রুফ করে দেখানো পসিবল, বাট এটার থিওরিটিক্যাল রিজনিংটা আমি পার্সোনালি এখনো খুঁজে পাই না কোথাও. I really looked for it, but I still couldn't find it. So we'll discuss about this specific thing that I just talked about eventually when the actual problem shows itself up, and we can actually dive into that problem. Then we have some of the graph related stuffs over here, which you know for sure. So that's pretty much it for the chapter for gas acceleration and gravitation. So let's dive into the worksheet. So very quick recap. I said 5 minutes, but it took longer than 5 minutes, but no harm done. Any questions so far?
No, sir.
Okay. আচ্ছা, এখানে অলরেডি প্রথমে যে কোশ্চেনটা দিছো, kids, you cannot see my group chat because that's how Zoom works. I mean, আমি এখানে Zoom এর অপশনে গিয়েও আমি যে Zoom এর গ্রুপ চ্যাট যে আমি মানে আমার ভিডিওতে দেখাইতে পারবো, এটা আমি ম্যানেজ করতে পারতেছি না. I mean, showing group chat to everyone is not an option that they have provided me. So here in this location, I have my group chat and my participant list. That's why my window is only up to this much. So don't worry about this one. একটা প্রবলেম দিচ্ছে হচ্ছে পেজ নাম্বার 17 14b.
Yes sir.
আচ্ছা, কোশ্চেন 14 আমরা দেখি. A particle is following a circular path and is observed to have an angular distortion of 10.3 degree. Express this angle in radians. Okay. Show your working and give your answer to 3 significant figures. Okay. আচ্ছা, দুটো বলছে determine tan theta degree, tan 10.3 degree to 3 significant figures. You calculate this number. গেল. কোশ্চেনে বলছে hence calculate the
ওখানে ওই যে B1 যেটা, ওখানে tan কি 0.3 ডিগ্রিটা যদি ক্যালকুলেটরে দেই তাহলে অ্যানসার তো ম্যাচ করতেছে না. মানে ওরা তো ডিগ্রিটা দিতে বলছে, কিন্তু রেডিয়ানে দিলে হচ্ছে গিয়ে ম্যাচ করতেছে. মানে ওইটাই বুঝতে পারতেছি না কেন.
You are not what? কেন? কি?
হ্যাঁ, মানে আমি জানি না.
The value
ডিগ্রি দিলে ম্যাচ করে.
আমার করে নাই.
আমার তো ম্যাচ করছিল.
0.182 আসে নাই?
0.182 তো আসে ডিগ্রিতে.
আসে স্যার.
ওটাই তো রেডিয়ানেরটা. আগে যেটা বের করলাম।
না, এটাতে ক্যালকুলেট করে আসে। তুমি এটা করার পরে ক্যালকুলেটরকে ডিগ্রি মোডে নাও আগে।
হ্যাঁ স্যার,
নিয়ে তারপরে 10.3 বসায় দেখো এক্স্যাক্টলি এই ডিজিটে আছে তো। 0.182
ওই একই জিনিসই আসছে আবার 0.182।
হ্যাঁ, 182 পর্যন্ত আসতে হবে। এই দুটো নাম্বার ডিফারেন্ট হবে।
ও আচ্ছা,
এটা তো হচ্ছে 10 নিউমেরিক্যাল ভ্যালু, আর এটা হচ্ছে রেডিয়ানে কতটুকু হয়। এরপর আমরা এই দুটার এরর বের করতেছি।
ও আচ্ছা, এই কারণে আমি ভাবলাম যে এত সেম।
না, these two numbers are not supposed to be equal, but we assume them to be quite equal. Hence the idea that for a 10 degree angular space we can still consider the simple pendulum to be a simple SHM object, because those two values are pretty close. That's the reason.
আচ্ছা স্যার।
আচ্ছা, ব্যাক করি এখানে খুঁজে নাও। Hence calculate the percentage error that is made when the angle of 10.3 as measured in radians is assumed to be 10.3 degree. আচ্ছা
স্যার,
আচ্ছা না, hold up, আমি তারপরে আরেকটা জিনিস বলি যে one of the key things that students do make a mistake or they get confused by that, উপরে তো আমরা ডিফারেন্স বসাবো কারণ পার্সেন্টেজ এরর বের করতেছি, so we're going to replace the difference of this value and this value. নিচে কি বসাবো? What's going to go on the denominator side? Should we place this one 0.182 or should we 0.180, or should we place this one 0.182, or should we use an average of these two? So that's a bit of a confusion that kids come by. Now you need to read the question. The question will help you. Hence calculate the percentage error that is made when the angle 10.3 degree as measured in radians is assumed to be equal to this much. what is considered to be assumed? Here, which one is considered as which one is assumed to be equal to something else?
10.3 degree.
10.3 angle as measured in radians is assumed to be equal to something, which means you are assuming this thing to be equal to this one, not the other way around. Read.
Sir, essentially 10.3 is wrong.
No.
Something like that.
10.3, no. It is assumed that this angle value is equal to
10.3 is the actual value, right, sir?
Exactly, that's what I'm trying to mean.
Yeah.
So basically 0.182 minus 0.18 divided by 0.18 into 100.
You have to
divided-
in your calculation process you have to write the zeros. 180, 0.180, 0.10 লিখতে হবে. In your
Yeah.
calculation you must write those. They might not mathematically mean anything, but examiners will look for your understanding of SF and everything.
Yes.
বুঝছো কি বলছি?
Yes, sir.
আচ্ছা। So, Polman, এই যে বুঝছো, one thing is assumed to be equal to the other one. So, the one that we are assuming to be equal, that is the errorful thing, and the one that we are considering to be equal to, that is considered to be the correct thing. So, what you really need to understand, which one goes at the bottom. We are assuming that this angle is equal to this one, so this angle's value goes at the bottom, which is considered to be the standard, and the one that we are assuming to be equal to be this one, that doesn't essentially put any value. Another thing that I can tell you is that for in your AS level, in your lab courses, you have done percentage differences. Remember? In your
Yes, sir.
AS courses,
Yes,
in
sir.
question number 2, you have done percentage differences. One of the key idea for those percentage differences was that whenever we are calculating any quantity that we don't know from previous experience, we are calculating is first hand, then the procedure in generally was that you place the difference of those 2k values in your numerator side, and then you place the average of those two values on your denominator side, and then you find out the percentage error by into 100%, which worked. But if that is the applicable case when you are assuming that the average of those two numbers that you have k values that you have calculated is basically the true value that you are assuming. But if that was not the case, if you already previously from previous experience, if you know the true value of someone, then you're going to use that one. Namely speaking, let's say you do some calculation, and by after you do some experiment to measure the g of an ছেলে বাইরে ফেলবে, তোমার কাছে নিয়ে রাখো বা ওই আমার রুমের বাইরে রাখো, এমন কোথাও রাখো যে না হাতে না, sorry. So let's say if you are trying to measure the gravitational acceleration by the use of a simple pendulum. Now in that case, you know for a fact that the constant value of gravitational acceleration is 9.81 meter per second square. So you might get something else with your experiment, but in that case you're not going to start doing averaging of your numbers, because the constant that you're trying to find out is a pre-known constant. So you're going to place delta at g, you're going to place on the numerator side g actual difference g experiment, niche asbe hocche g actual. So the bottom denominator should always be the truest of the value that you might either know from previous experience, or if you don't know, the only choice you have is to go for averaging. So that's the idea that is being applied over here. We are assuming this number to be equal to this one. So this is your standard value, and this is your assumed equal value. So get the information. Does it make sense?
Yes, sir.
Yes, sir.
Thank you. Achha, then we have another problem at page number 19, B22.
Sir, page number 21 হবে. Sorry, sir, ভুল লিখছিলাম।
আচ্ছা সমস্যা নেই।
Question number 19.
আচ্ছা ঠিক আছে, 21 গেছি। Question 19 এর content আমরা একটু দেখি। A spherical planet has mass m and radius r. The planet may be assumed to be considered to be isolated in space and to have its mass concentrated at its center. The planet spins on its axis with angular speed omega as illustrated in figure 1.1. A small object mass m rests on the equator of the planet. The surface of the planet exerts a normal radiation force on the mass. Okay. State formula in terms of m, r, and omega for the gravitational force between the planet and the object. আচ্ছা এটা তো পারছো, তোমার প্রবলেম হচ্ছে বি তে
Yes, sir.
বি তে সো A1 2 3 এক্সপ্রেশন গুলো সবই পারছো আচ্ছা B1 এ বলছে explain why the normalization on the mass will have different values at the equator and at the poles আচ্ছা
এটাও পারছি sir.
এটা পারছো
B এর 2 এর 2টা পাইনি।
আচ্ছা the radius of the planet is dysfunction is completes one revolution in a second therefore the manage to the centripetal acceleration আচ্ছা এটা হচ্ছে রেভলিউশন এখান থেকে আমরা বাই করতে পারবো হচ্ছে ওমেগা আর এটা হচ্ছে আমাদের r সো m ওমেগা স্কয়ার r মানে এখান থেকে আমরা
নাম্বার কোশ্চেন জানি
এটা হচ্ছে 19 ও এটা তো জাস্ট জিরো হবে
হ্যাঁ মানে
কোনো
রেজাল্টটা বুঝি না।
এখানে কোনো ক্যালকুলেশন দিবে না খালি খালি এখানে জিরো লিখবা
রেডিয়াস 0 দেখে এটা ছিল মানে ডিসটেন্স 0
বলতেছি এখানে যখন আসে তখন whenever the particle is located on the equator it is undergoing a circular motion of this much big ঠিক না
Yes, sir.
whenever it is placed over here it is going in a circular motion of this much big the latitude longitude the latitude circle then if it is placed over here it is going in a circular direction like this if it is placed exactly on the equator there is no circle anymore
Oh, right. Good.
make sense
Yes, sir. Thank you.
so yeah sure the amount of space that you can see over here that both of these questions are provided with equal amount of space it is a clear indication kid do the work it's a math you have equal space so we expect you some working they do this deliberately so that you kids waste time do mistakes but if you have a look at the marks there is the clear indication that where a working is expected where a working is not expected do you see it so they'll do this every once in a while they'll give you a amount of space to do some mathematical working where you are not even expected to do a mathematical working the reason is good enough and the answer is simple enough the next question that auditor posted was page number 15
Yes, sir.
12C acha we'll go for that see what is meant by field of force two protons are isolated in space their centers are separated by a distance r each proton may be considered to be a point mass and with point charge determine the magnitude of the ratio acha I get the question one of the part is that the force between two charged particles which is the electrostatic force this is a topic that which comes from Coulomb's law which is quite identical as in Newton's gravitational law but we teach this in chapter capacitors and electric fields so we go for that chapter you haven't come across this formula yet so but it's a very simple formula you can for the time you can skip this thing because that is not already taught to you but ultimately we'll learn about that so I'm skipping the solution for this problem for the time being because I did not teach you the idea for gravitational field so electric field so eventually when you learn that we can come back to this problem if you cannot solve it on your own anymore or if you can solve it on your own automatically then it's just done so write later on the left side of this question we're not going to do this right now
Okay, sir. Thank you.
now we do acha Arnob Shaha কিছু প্রবলেম দিছো নাম্বার 2B 19C 22C 2B টা একদম উপরে হবে Today was say explain why the values of gravitational potential near to an isolated mass are all negative. Acha. You know this answer, but maybe it was a problem in the wording. Am I correct?
Yes, sir.
Acha.
স্যার এর আগের সলিউশন ক্লাসে একটা
থার্ড ওয়ার্ক ডানের
Wait. অর্ণব তোমার কথা কিছু শুনি নাই বাবা কথা কেটে যাচ্ছিল I don't know why but it was getting cut off
মার্ক স্কিমে থার্ড পয়েন্টটা বুঝিনি
আচ্ছা ঠিক আছে মাসিনা থার্ড পয়েন্টে দেখতেছি রাফিদ কি বলতেছিলা বলে ফেলো
যে এটা একদিন আমি জিজ্ঞেস করেছিলাম আপনি বলছিলেন যে the word got out of the system বলছিলেন পরে জানাবেন তো এটাই
ও আচ্ছা ওটা লেখা আছে এখানে
হ্যাঁ the word got out of the system মানে এরকমই একটা কোশ্চেন এটা নাকি না শিওর না
হ্যাঁ সেটা তো আমরা লাস্ট ক্লাস ডিসকাস করেছিলাম আই গেস
আচ্ছা what do we mean by the phrase work getting out of the system let me explain this thing if we apply external force against the prevailing force within a system, in that case, our physical work done on the system is stored as energy. That is an expression that we call work going in. Name the example. Let's say you have a undeformed spring attached to a wall or something like that. Whether you stretch it or you compress it, you will have to do some application of force against the inherent force of the system. If you try to stretch it, the spring is going to try to pull it away. If you try to push it, compress it, the spring is going to try to push it outwards. So the spring will always produce a force against your application of force direction. So whenever you are doing some applying some force onto the system and doing some actual work against the system's force, additional work is done on the system and energy content of the system goes higher. The amount of work that you do is stored in the system as energy. This idea is exactly flipped or reversed, and then we can say that, I mean, let me just reverse it as identical as possible, that external force working on the system makes work go in / energy going higher. Systems force itself working on its components makes works go out / energy content goes lower. Now, if you wonder over here, the question that you asked in the last is that, well, GP is converting to kinetic energy, then how the system is losing energy? System is not essentially losing energy. What you need to understand, due to gravitational force, for that force you have GP. As the two objects get closer, the GP stored between the two objects becoming less. GP is converting to other type of energy. The total energy of the system is remaining constant, but the force, by the virtue of gravitational force, that is the gravitational potential energy, that quantity is becoming smaller. That's what is meant by the word by the word work goes out. So it's still, the total energy is still same. So portion of the GP converted to portion into K, but the amount of GP is becoming less whenever the planet is getting closer to the I mean, the test object is getting closer to the field creating mass. That's what it means by the word what goes out. See if it makes sense.
Sir, here work is referred to as the stored potential energy.
GP, yes.
GP.
Yes. Did it make sense?
Yes.
Okay.
Sir, ব্যাপারটা কি এরকম না যে যখন মানে অবজেক্টটাকে একটা গ্র্যাভিটেশনাল ফিল্ডের মধ্যে মুভ করে আমরা মানে নিয়ে যাচ্ছি স্যার ক্লোজার টু দ্য অবজেক্ট আনাদার অবজেক্ট, তখন তো বেসিক্যালি ওয়ার্ক স্যার কম করা লাগছে আমাদের, লাইক
we don't have to work
comparatively আমাদের যদি এটাকে
we don't essentially have to work. I mean, because the available force within the system will be doing the work to get them closer. That process might be slow, but the force available from within the system is good enough to make that happen.
So we are not doing any work automatic হইতেছে যেহেতু, so energy is basically lost.
Energy of that form is lost, but not altogether lost. The GP is reducing, not the total energy is becoming less anyhow. Portion of the GP is converting to portion into of K. So total amount of energy in the system is remaining same, but GP reduces and K increases.
স্যার, আমার সাথে প্রশ্ন ছিল যে আমরা তো স্যার জানি যে নাল পয়েন্টে হচ্ছে কি আমাদের গ্র্যাভিটেশনাল পোটেনশিয়াল মানে জিরো থাকে একটা পয়েন্টে।
না বলবো স্যার,
তাহলে
সেন্টেন্স আরেকবার বলো স্লোলি বলো।
আমরা তো ইনফিনিটিকে ধরি যেখানে আমরা বলি যে পোটেনশিয়াল ইজ জিরো, তো আমরা
null point is the point where the gravitational field strength is zero. Potential between two planets is never zero. It is minimum but not zero.
আচ্ছা স্যার, কিন্তু তাহলে নেগেটিভ এর সাথে অ্যাট্রাকটিভ এর কি মানে গ্র্যাভিটেশনাল ফোর্স ইজ অ্যাট্রাকটিভ এই পয়েন্টটা ওখানে কেন দিছে? মানে দুইটা তো দুই জিনিস।
আচ্ছা ঠিক আছে, এটা আমি এক্সপ্লেইন করতে পারবো। এটা এক্সপ্লেইন করার বেসিক আইডিয়া হইতেছে যে the formula for electrostatic attraction forces is pretty much similar as gravitational formula. Let me just write those formulas side by side just to give you a better understanding point. We write Fg equals to G mm by r square. Let's say Newton's law. Coulomb's law, force due to electrostatic attraction or repulsion, is given by K QQ by r square. Have a look, they are exactly identical in shape, right? But the difference is that charge can be individually plus or minus. It is possible for charge to be plus or minus. Not essentially, don't assume that here Q is plus and small q is minus. No, charge can be plus or minus on its own virtue, but there is nothing as negative mass.
Yeah.
So that's why. So adaptogenation. Now try to understand this part. For that, I mean, disregard this formula. Have a look at this equation. We know that like charges repel and opposite and unlike charges attract, right?
Yeah.
This equation itself has a positive value. Our distance will always be a positive number. So I can go to question 9. So ultimately, what will be the total sign of this total fraction? It is highly dependent on the signs of these two variables. Now think about this. If both of these variables are positive, plus and plus, after multiplication you will get the force to be positive, which is supposed to be a repulsion, because two positive charges will repel each other. It's not mathematics, it's basic understanding. If you apply two positive charges value by the exact sign of charge, you'll have a positive sign over here, positive sign over here. After multiplication, you'll once again come up with a positive sign. So that would mean that the force of repulsion between two positive charges is a positive force.
Yes,
Similarly, if you have two charges which are negative, if both of the objects used to be negative, so Q negative, small q is also negative. If you do the multiplication, you also get that force to have a positive sign. These two negative charges are also supposed to repel each other. So you can see that for whether the two objects are both positive or both negative, you are having a repulsive force always where the sign is actually plus. On the other hand, if one of the object is positive and the other object is negative, vice versa applicable, the product is going to give you negative. And in that case, the two charges are supposed to attract each other.
Yes, sir.
So from these concept, we give this idea that for the case of field and everything, if a force is to be represented as a positive force, it is represented as a repulsive force. And if a force is negative, it is representing a attractive force. Now, gravitational force only has its attractive version. We human beings could not yet discover the repulsive version of gravitational force. We couldn't. Maybe it doesn't exist, but we couldn't yet observe it anywhere in the universe. That's because gravitational force is always positive. That's why we are calling this as a negative force, and that's why gravitational force always makes the system's energy less.
স্যার ইথারের কনসেপ্টটা কি অনেকটা এরকম ছিল না যে আউটসাইড থেকে আমাদের ফোর্স কাজ করতেছে something close to that?
Ether was a totally hypothetical idea, which was wrong, to be honest. Abhias, bolo, you have a question. I mean, ether niye ami beshi alap kortechi na because ether was a wrong assumption of the scientists, which was discarded altogether once it was proved wrong. So it's not very interesting to me. Yes, Abhias.
Sir, your explanation of Coulomb's law with positive and negative charges and why it is attractive and repulsive, that makes sense, but mass can never be negative, sir. So do we, in a predetermined way, just take all gravitational force as attractive regardless of its sign?
Exactly. The point is that physical observation allows us to see that the force between two masses would always be attractive. So two masses will always attract each other. So M and M, irrespective of their magnitude, they'll always attract. And because we could not find a reverse version of masses, so we don't bother giving the masses plus or minus signs. I mean, if you wondered that here the two attraction forces, they had different signs. So you might wonder that, well, in that should essentially mean that this mass and this mass, one of them should have plus and another one should have a minus sign. Just by comparing this equation, that is not essentially required because we don't essentially find any difference in the physical property of the two masses which attract each other. That might be a proposition from the equation comparison, but that's not essential because we don't see any difference in these masses in terms of their mass property. One of them might be big, one of them might be small, but they have the mass is the same property that these two objects have. So there is no physical reason or logical reason or logical mathematical or logical reason for us to give plus or minus signs for the two masses, because they are pretty much identical for the property of mass. What we can say that because the product will give us a force that we can calculate out of this equation, and because this force is always attractive, that's why we're going to call this force a negative force. We're not essentially defining the in-between variables of this expression as plus and minus for the gravitational equation. We're not. Just a second. Abel, did it make sense to you?
So the math is pretty much limited by the physical observations and stuff.
Yes, definitely. I mean, every type of physics or science that you do, it has to be mathematically consistent and it has to be physically repeatable. Only then you can call it a theory.
Yes, sir.
Make sense? Sure.
Yes.
Sajid Alam.
স্যার এই আপনি যে ডান দিকে যে চার্জের যে জিনিসটা বোঝাচ্ছেন এটা কি গ্র্যাভিটেশনাল চ্যাপ্টারে লাগবে?
এটা গ্র্যাভিটেশনাল চ্যাপ্টারে লাগবে না, বাট তোমাদের A2 সিলেবাসে আছে। It is included in A2 syllabus. It will be
পরে তো আসতেছে।
Yeah, it will definitely show up later. I just use this expression because this is a small part, just to give you an explanation in my opinion. So I just showed you the idea of mathematical multiplication. There is nothing. I did not tell you what all of these parts are. I just want you to concentrate on this much part of the equation, that A2 ke multiply korle ki hoy. That's all I wanted to consider.
আচ্ছা স্যার ওই যে আপনি যে বলতেছেন না যে ফোর্স গ্র্যাভিটেশনাল ফোর্স যে নেগেটিভ ধরা হচ্ছে, এটা কি বোঝাচ্ছেন? আমি বুঝতেছি না, মানে এটা কি বলতেছেন? গ্র্যাভিটেশনাল ফোর্স প্রত্যেক সময় অ্যাট্রাকটিভ হয়, তাহলে এটাকে নেগেটিভ বলতেছে।
Because from this equation we can see that the attractive forces can be represented as negative forces.
বুঝলাম না।
The force between two objects that happens because of one phenomenon, electrostatic phenomenon or gravitational phenomenon, we can see over here that like charges would repel each other and unlike charges will attract each other. For unlike charges, the force value would have a negative sign.
Oh, আচ্ছা বুঝছি।
Okay. Raya.
স্যার এখানে কি সিচুয়েশনটা এরকম হচ্ছে, in electric field when there are two attractive forces between two oppositely charged objects or particles, the field direction is in the field is in one direction only. So it's basically যখন আমরা একসাথে field direction গুলো আঁকি, সেগুলো সবকটা field direction একই সাইডে হয় বা একই ডিরেকশনে হয়। বাট ইন দ্য কেস অফ গ্র্যাভিটেশনাল ফিল্ড, আমরা যখন field line গুলো আঁকি, they're in opposite direction. So basically an object is attracted to different sides at the same time, like to the different masses যখন একটা object is in that gravitational field.
Are you talking about the depression of the gravitational field, those three-dimensional graph things?
No.
I couldn't comprehend your question. আবার বলো।
স্যার ওই যে আপনি যে বললেন না যে যদি আমি আর্থ থেকে মুনের দিকে যাই, there is one null point যেখানে দুইটা gravitational field strength cancel out হয়ে যায়।
Yes.
So basically আমাদের তো in electric field we are being pushed from two sides যখন
opposite charges.
হ্যাঁ,
yes,
but এখানে gravitational field we are pulled to both sides, so that nature is different in both fields. এই কারণে কি gravitational field is always attractive no matter what the mass is.
I get your question, but I cannot give you a hard yes or no for this answer because I am not sure if the logic that you just told me, that is the basis of defining the gravitational force to be plus and minus. I don't know this for a fact, but the logic inherently sounds logical or consistent. What I know for a fact is that, I mean, if I go in a bit deeper idea, just to entertain your question, whenever we define the force of a field, we take a standard to define the force of the field. For example, for gravitational cases, it is 1 kg mass, unit mass. And for electric fields, it is +1 coulomb charge, unit positive charge.
Yes.
So we define the sign of the field of the gravitational field based upon in which direction that standard experiences the force. Now, 1 kg mass would always experience force to any of the other gravitational object.
Yes.
Mass, that is, by using the term gravitational object, I mean mass. So it will be attracted by all the masses altogether. There would never be a repulsive version of it whatsoever. But any unit positive charge would get repelled by another positive charge, and it will get attracted by another negative charge. So electrostatic forces can have positive and negative version both based upon our standardized comparison. That's the reason that you would always have an attractive force for gravitation, but the electric field can give you attraction and repulsion both.
Okay, thank you, sir.
That's what I know for a fact that I can vouch upon. But the question that you asked me, I got your question, but I do not know the answer of that question to give you a hard yes or hard no. I don't know this.
Okay, sir.
Yes, Shubho.
স্যার আমার কোশ্চেন ছিল যে গ্র্যাভিটেশনাল ফিল্ডের যে গ্রাফ টাইপ ডিপ্রেশন গুলো থাকে না স্যার ওগুলো তো গ্র্যাভিটেশনাল পটেনশিয়ালের থেকে মেজার করে দেয় তাই না?
Yes. Yes.
হ্যাঁ স্যার আপনি একবার আমাকে বলেছিলেন, আচ্ছা বাদ দেন ওটা, দ্যাট ইজ আ বিট আউট অফ টপিক আই গেস।
তাহলে ক্লাসের পরে রেকর্ডিং শেষ হওয়ার পরে জিজ্ঞেস করো,
ক্লাসের পরে
তখন আলাপ করব না। if it's within my capability I'll entertain your question, no big deal.
স্যার ওই এর লাস্ট পয়েন্টটা যে সো ওয়ার্ক গট আউট ইন মুভিং টু পয়েন্ট, তার মানে কি ওইটাই বোঝাচ্ছে যে জিপি কেই হয়? আর মানে সিস্টেমের কি এনার্জি বাড়ে না কমে, মানে গট আউট মানে কমার কথা বলতেছে?
সিস্টেমের টোটাল এনার্জি বাড়ে না বা কমে না, সিস্টেমের গ্র্যাভিটেশনাল পটেনশিয়াল এনার্জি যেটা স্টোর করা ছিল সেটা কমে যায়।
আচ্ছা স্যার, বুঝছি।
I mean, logically try to understand. If the two objects are really far apart from each other, they would have one amount of GP stored by virtue of their gravitational potential. But if you bring them closer, that GP would have been much more smaller.
Yes, sir.
So that's the idea.
So basically, potential energy goes out as kinetic or other forms of energy.
Yes, other forms of energy. Yeah, exactly. Okay. So this was a very good question for idea-based question. This was a good one. Nice pick. Then we have question number 19C. We'll have a look at 19C. 19C কত নম্বর পেজে? Down. So this was 19 and this was 19C. Oh, acha, that same question. Okay. Arnav, have a look, and everyone else. Suggest two factors that could, in the case of a real planet, cause variation in the acceleration of free fall at its surface. Well, one of the factors that we know already. One of the factors that we know is that the shape of the Earth is not a perfect circle. It is more wide, or it has a bigger radius around its equator region. It has a smaller radius around its polar region. So the variation of the what? Of the
free fall.
Of the if the planet is not uniform, then that radius would be different at different points, so we'd have different values. That's one of the points that I can think of. What could be an second factor? Acceleration of free fall vary করার জন্য আরেকটা ভ্যালু আরেকটা হতে পারে কি? আরেকটা কি হতে পারে?
The mass of the planet.
Mass of the planet can be considered to be concentrated at the Earth's center.
So difference in the centripetal forces at different location.
Yeah, but there can be like differences in.
Sir, কারণ distance তো differ করে।
Movements of other planets around it.
এটা কি আমরা অলরেডি এখানে কভার করি নাই?
Maybe not.
না। আচ্ছা, সরি, এটা আমরা এখানে অলরেডি ডিসকাস করি, মানে আচ্ছা, সরি, I was a bit what is called tunnel vision. They have only said suggest two factors that could, in the case of real planet. They didn't say that other than something. I was assuming that this point that we have already covered over here, that there is a variation of gravitational acceleration due to the location. I mean, on the equator you'll require a bigger centripetal force. As you slowly get closer and closer to the pole position, your requirement for centripetal force will become smaller. So your effective G value would become larger. So that can be also said that the particles close to the equator region or equator line would require a bigger centripetal force, so its G would be smaller. As approach towards the polar region, their G value will increase because a smaller fraction of the gravitational force would be required to maintain centripetal circular motion. So these are the two things. একটা হচ্ছে shape, একটা হচ্ছে location on the planet. That's all I can think about right now. But we might as well look at the Mars scheme to see what the examiners are thinking.
The density, the shape of the planet, I guess. The density of the planet.
So one of the points they have given us in terms of example, which is very liberal in my opinion. Radius of the planet varies, which we covered. Density of the planet not constant. Actually, if you wonder why density of the planet not constant is a factor, I mean, Earth is mostly uniform in terms of its density, but it's not impossible that some other planets might have a shape like this. Let's say this is a planet, and হ্যাঁ ওটাই বলতেছে মানে এটা হচ্ছে প্ল্যানেটের উপরে খানাখন্দ আছে and everything. Maybe it is possible that somewhere within this planet there is a very large gas pocket. This is essentially impossible. So let's say this part of the planet is this is the actual solid part. এখানে অনেক বড় একটা gas pocket আছে. So if that is a scenario, which is not impossible in geotechnological sense, I'm not sure if that's the word to use. Anyway, you get the point. If within the construction process, I mean, there are significant air gaps or gas pockets in the planet, then your COG might not be exactly same. So for this planet, the COG might be located somewhere over, let's say, maybe over here, where you have a bigger amount of mass. So it's not essentially at the geometric center. It should somewhat move towards the more massive side. So that variation will also give you a difference in the G measure. Yes.
Sir, আমাদের ইয়েতে হবে না মানে কনস্ট্যান্ট হবে না আমাদেরটা because lava আছে
Earthের জন্য এটা applicable না because Earth's lava is a liquid, so it's pretty much uniformly distributed. But if you consider the gas pockets that we have, I mean those gas pockets those gas pockets that we have discovered for the case of Earth, they are not significantly large like this. The center of the Earth is pretty much liquid molten lava, so it's almost with no physical gas thing. So
we are not even sure center ki ache.
We're actually almost sure center ki ache by means of distance calculation, but we're not exactly sure. I can say almost sure because we were not there and didn't take samples out of the liquid lava. But pretty much for every case, I mean, the deeper you dig in, eventually you will get hot. It will get hotter and hotter and hotter, which gives us the idea that at the center it will be more hotter, and at a certain point you might reach the temperature of the melting point of the soil, which is basically lava. So that's the generalized idea, but well, it's not essentially possible to dig deep within and go through this process unless there is some science fiction movies. So I think that I made the idea of the density thing appropriate, which is a very good point. I just didn't pop in my head. Planets spinning or nearby planets or stars. So they did not at all mention the idea of different location. So they have given 4 marks over here. Any sensible common 1 mark each.
Spinning ta ki centripetal force ta ke refer korche?
Spinning radius ta centripetal force ta ke refer korteche. Yes.
Spinning ta keno important?
Because at different locations on Earth, you would have different radius of your spin. Because you would be spinning around the on a circular path, which we call the latitude lines. If you're over here, you're not going to spin like this. You're going to spin like this. So you'll have a smaller radius compared to what is going on over here.
Yes.
লোকেশনের জিনিসটা তো আসতেছে তাহলে
হ্যাঁ লোকেশনের জিনিসটা আসতেছে বাট এখানে মার্স স্কিমে লোকেশনের জিনিসটা স্পেসিফিকলি ওইভাবে বলে নাই they have just say planet spinning আচ্ছা আমি যে পয়েন্টটা বলছি সেই পয়েন্টটা হচ্ছে প্ল্যানেটের স্পিনিং থেকে এফেক্ট করে that might as well আচ্ছা let's have a look at the Mars scheme examination report দেখো C number 19 C the examination report say the most frequently quoted answers include reference to the planet not being spherical and to variation of the density of the metal of the planet. Some did refer to nearby moons and planets. So Rafi's data randomly bolster the nearby planet or stars hobe kina, you can see that it is also included. So that might be a good response as well.
স্যার কেন স্যার আমি বুঝলাম না মানে নিয়ারবাই প্ল্যানেটস কেন আমাকে গ্র্যাভিটেশনাল অ্যাক্সিলারেশন কে এফেক্ট করতেছে
ওরা তো অ্যাট্রাক্ট করবে কোনো অবজেক্ট যদি থাকে বা ম্যাস
not essentially attract করবে. Let's say এটা হচ্ছে Earth. Let's say এটা হচ্ছে Moon. Moon mass is not insignificant. Okay, let's say this is you. You are having yellow color by that famous guy in Facebook. What is his name, Jenny?
Oppo bhai.
Yeah, that one. So let's say this is you. ঠিক আছে? Whenever the Earth is going around, and let's say whenever you're over here, Earth is pulling you to the left, Moon is pulling you to the right. So you are going to press the Earth's surface by definitely a significantly smaller force compared to when this thing happens. You're definitely not going to go through the Earth's core. It will happen at a different time of the day. Earth has rotated, Moon has rotated, and at some other point of the day, a time frame of the day, this can happen, that you are on the opposite side of the Moon. In this case, Earth is pulling you to the right, Moon is also pulling you to the right. So together that pull would essentially give you a much bigger force of pushing onto the ground. Do I make sense?
Yes, sir.
It's about your relative position with respect to where the planet is and where the other things are located. So based upon that, you can have difference. Basically, to be honest, this is the exact this idea of force variation that I just discussed is the key reason why we have high tides and low tides on Earth. This is the reason.
আচ্ছা আচ্ছা
স্যার এটিকে আরেকবার বুঝাবেন, মানে ক্যাচ করতে পারিনি কি হবে?
Whenever you are in between the two things, the Earth and the Moon are gonna pull you in opposite directions. So you are going to apply your weight or your remaining force on the Earth's surface by some value, whatever that value is. Okay, but you are essentially having a significant part of the force, what can I say, a significant portion of the force balanced out by the pull of the Moon towards the right. But in a different time frame of the day, when this will happen, that you are located exactly on the opposite side of the Moon. In this case, Earth is pulling you to the right, and also the Moon is pulling you to the right as well. So those two attractions are going to sum up together. So you'll be pressing the Earth's surface at a much more stronger value compared to what you could do if you are located here. That's the difference. So the other celestial bodies which are around can effectively affect how much force can you exert on your own planet.
তাহলে স্যার ওই যদি আমি
এক মিনিট আমি কোশ্চেন নিচ্ছি, একটু দাঁড়াও, একজন করে। মিথিলা বুঝছো?
মানে স্যার মাঝখানে থাকলে হচ্ছে গিয়ে ওয়েট বেশি থাকবে,
ওয়েট কম থাকবে।
আচ্ছা হ্যাঁ, ওয়েট কম থাকবে আর ওই সাইডে গেলে ওয়েট বেশি থাকবে, বুঝছি স্যার।
ঠিক আছে, হ্যাঁ সাজিদ বলো।
স্যার ওই ধরে নেন আমি হচ্ছে গিয়ে এখন মুনে যাব, ঠিক আছে? তো আমি এই যে ইয়েলো যে পয়েন্টটা আছে, ইয়েলো পয়েন্টটার থেকে একটা স্পেশাল নিয়ে আমি লাগলে ইয়ে করলাম, আর আর্থ অ্যাটমসফিয়ার থেকে উপরে উঠতে থাকলাম। এখন এই কেসে তো মুনটা আমাকে না ওই উপরে না, মুনের দিকে আর কি। তো এই কেসে
তুমি লাভ দিয়ে তো মুনে যেতে পারবে না, তোমাকে মুনে যেতে হলে এমনি করে আসতে হবে।
এভাবে আসতে হবে কেন? আমি আচ্ছা আচ্ছা হ্যাঁ
লাভ দিয়ে তো মুনে যেতে পারবে না। You cannot go in a straight line like moon. মানে typically the way orbits work, I mean if I just I'm gonna keep this guy over here, এখানে থাকুক। মনে করো তুমি আর্থের এই পয়েন্ট থেকে যদি মুনে যেতে চাও, মনে করো তুমি আর্থের এই পয়েন্ট থেকে যদি মুনে যেতে চাও, if you want to make a journey from let me use green, let me use blue, dark blue. If you want to go from this point to moon, you cannot directly take a leap like this. You have to, just to do the Earth's rotation, you shoot your rocket, you make a track like this. In most cases, you make it up like that, and then you can land up over here. That is the most common type of trajectory, which makes the journey safe and energy efficient.
Energy efficient এত distance cover করার পর,
হ্যাঁ, because most of this journey is made by using the centripetal force. Free gravitational force that you have. তোমার ফুয়েল বার্ন করতে হবে কম, আর তুমি যদি এখান থেকে ডাইরেক্ট সোজা বাড়াতে চাও তোমার প্রচুর ফুয়েল বার্ন করতে হবে।
This partly resembles polar graphs, honestly.
স্যার বাট এইটা তো তাহলে ডিসটেন্স বেশি যদি কভার করে লাইক টাইম বেশি লাগতেছে, এটাও একটা ডিসঅ্যাডভান্টেজ।
Yeah. It would definitely require a bigger time compared to having a straight line journey, but you have to understand one thing. In celestial journey processes, only the location is not important. Time is also important. I mean, let's say I'm gonna go into moon. It would take me 24 hours to reach to the moon. I have to calculate that I have to start my journey not aiming at the position where the moon at. I have to start my journey aiming at the position where moon is going to be after 24 hours. So you have to start your journey aiming at a blank point in the space. Within 24 hours, moon is going to appear there. So what and when, both are equally important in the case of a space journey. Does it make sense?
Yes, sir.
Yes.
So yes, that was that. So I think this question is answered, right?
স্যার আমি 19 এর A3 আর B1 টা বুঝি নাই মানে এই একই কোশ্চেনের A3 আর B1
We've been explaining A3 for the last 10-15 minutes.
না না স্যার ওই নরমাল রিঅ্যাকশনটা
Yeah.
মানে এটার ভ্যালুটা আমি বের করতে পারতেছি না
How is that related to
This-
MMR?
বুঝছি আমি তোমার কোশ্চেন বুঝছি আমি দেখাচ্ছি don't worry it's a problem I'll solve it no big deal okay hold on, you guys do understand that I am still using a mouse for my drawings, right?
Yes, sir.
And I'm really good at it, right? Not bragging or anything.
Yes,
Oh,
sir.
you are.
Actually-
Sometimes I forget that you
Yeah.
are using the mouse.
Okay. কি যেন দেখাতে যাচ্ছি আচ্ছা হ্যাঁ ইকুয়েটর রিজিয়ন আচ্ছা বুঝাই let's say the person or the planet is whatever that is. Let's say that is a cubic object. Let's use a cube shape for my purpose right now. Let's say this is you, okay, or this is the object located here. Now this object would require a certain amount of force towards the center to maintain a circular motion. By logic, it has an available default amount of gravitational force which is working to the left. ঠিক আছে? Let's say this is the amount of gravitation. Let's say this is the amount of gravitational force that it has available due to its pull of mass and mass. From this force, you would require to spend a small amount of force to maintain the circular motion. Let's say this is the amount of force that you have to spend to maintain the circular motion. So you have this much available from gravitational happening. You have to spend this much to maintain the circular happening. So the amount that is left is what you are going to push the ground by.
Yes, sir.
Logicটা ধরে গেছে?
হ্যাঁ
I mean,
স্যার
could you visualize this properly altogether?
হ্যাঁ স্যার ওই FG থেকে একটা পার্ট FC হয়ে যাচ্ছে তো ওটা বাদ দিয়ে যতটুকু থাকবে
ওটুকু দিয়ে সে গ্রাউন্ডকে ঠেলা দিবে।
হিসাবে অ্যাক্ট হবে
Beautiful.
হ্যাঁ
আচ্ছা আরেকটা কোনটা বলছিল জানো?
স্যার B1
So, sir, it is basically G minus FC, right?
That's exactly what I said. B1, explain why the normal relation of the mass will have different values at the equator and at the poles. Oh, that is because as the person slowly goes above, the radius of the circle is going to become smaller.
So that force will be used as the centripetal force, right?
আচ্ছা আমি এটা নেটে খুঁজতে গেলে যতটুকু সময় লাগে ততটুকু সময় আমি এটা এঁকে ফেলতে পারবো to be honest. Let me show you. Let's say now this person has reached up over here. এটা আমি তোমাদের লেকচার করার সময় দেখাইছিলাম না নাকি দেখাই নাই? I have a slight feeling I showed this. Anyway, if I haven't, it might as well be a good point to show you right now. So have a look. Because this is now in a tilted position, I cannot use these beautiful arrows. I have to use my mouse cursor. So just bear with me and ask me questions if you have any. Let's say at this position, the gravitational force is working towards the center like this. Let's say this is the gravitational force that you have available, the green arrow. The direction of force. Sorry, the circle in which this particle is now undergoing circular motion, that would be this amount of circle, which means that circle's level would be this line. So the radius would be this much, because it's not going to go around the earth like this, because earth is going on its axis in a direction like that. So this particle is going to go like that. See if that this idea makes sense. Does this idea make sense?
স্যার আর্থের সেম ডিরেকশনেই যাবে না
What do you mean by Earth same direction? Yeah, Earth same direction এ যাবে, but that so that's exactly why its radius of circular motion would be smaller compared to
Yes.
the radius of circular motion over here. Can you appreciate that?
ওটা ধরতে পারছি।
ঠিক আছে, সো এখানে যদি আমাদের অ্যাঙ্গেল হয় থিটা, তাহলে আমাদের এখানে অ্যাঙ্গেল হবে থিটা, ঠিক আছে? So let's say this angle is FG. So if we do divide, do we have to divide this force? We actually have to divide this force. We require this much force for centripetal working. So let's say this is our FG. So you would have FG cos theta, and let's say you would have FG sin theta, both of which are vectors. Together they will make up for your Fg, which is the total gravitational force. Now what I need you to understand that as you have gone up over here, a small fraction of this Fg cos theta part would be used up as gravitational, as the centripetal force.
Yes, sir.
Not all of it. So the total amount that you would have remaining would be somewhat smaller than the actual Fg value, right? Now if you consider the requirement of the centripetal force, now have a look. In this case, let's say মানে আমাদের centripetal force এর basic একটা expression হচ্ছে কি, মানে if I choose the smallest formation m omega square r. If you wonder why do I choose this, I chose this one because we are considering the same object being moved from one place to another place. So m is a constant for both of these positions. Omega is 24 hours for each particle on the Earth's surface. So all that varies the value of the centripetal force is the radius r.
Yes, sir.
So at this position, the required centripetal force to maintain circular motion will be significantly smaller compared to the required centripetal force to maintain circular motion over at the equator. So here you'd have to spend less for available force to maintain circular motion compared to over here. So because you are spending less, you can have more left, which means you can push the grounds more strongly.
Sir, মানে normal contact বেড়ে যাবে।
Yes.
Sir, gravitational force ও বাড়বে না কারণ radius তো কমতেছে।
Yes, but the answer to your question is yes, but it is always better that you describe the effect of one of the factors at a time. So my answer to your question is yes, but don't mix both of these up in a single answer. Write them one at a time.
Sir, বুঝছি স্যার, বুঝতে পারছি।
Clear হয়েছে?
হ্যাঁ স্যার।
আচ্ছা, নাইস। সো এটা গেল। এখানে আর কোনো প্রবলেম কারো এই পোরশনটা নিয়ে? Anyone else? Apparently no. 22C. 22C কি নাম্বার না পেজ নাম্বার? আচ্ছা 22C কোশ্চেন নাম্বার। অর্ণব আসো?
হ্যাঁ।
আচ্ছা। এই গ্রাফটা তোমাদের আঁকা দেখাইছিলাম না লাস্ট ক্লাসে আমি?
Yes, sir.
And I made some amazing graphs using Painted. I was very proud about myself. That was really what is it called?
Satisfying.
Self love একটা ভালো নাম আছে, vanity.
That was narcissism.
That was for me, that was borderline vanity. I was like, oh my god. Anyway, I'll get my point.
Same expression for some other graph too, which I took screenshots of. So yes.
Number C is the problem, right? Number C3. This is the question that one of your friends asked. So let's go start from here and try to get the idea of it. The Earth and the Moon may be considered to be spheres that are isolated in space with their masses concentrated at their centers. The masses of the Earth and the Moon are 6.00 into 10 to the power 24 kg and 7.400 into 10 to the power 22 kg respectively. The radius of the Earth is RE and the separation of the centers of the Earth and the Moon is 60 RE as illustrated in figure 1.2. Beautiful. Okay, 60 RE, radius of RE, beautiful. Explain why there's a point. এটা আকানে ঝামেলা আছে তো অর্ণব?
Yes.
এটা আসলে লাগবে।
হ্যাঁ, এটা আকার প্রসিডিউর আমি তোমাদেরকে শিখিয়ে দিছি। I'll show you, don't worry. এগুলা কি? I learned a new word today morning. I might have come across this word earlier, but I never captured it to a quality that I might be able to use it for my purposes. But today I learned a new word. The word is nifty.
Come again?
Nifty.
As part of my everyday vocabulary, so
It was not for mine, so I feel enriched.
I know.
Learning new word is always an experience.
Yeah, exactly. I mean, yeah, I totally agree with you, Fariza. So for the first thing we're gonna do, with a thinner pencil, not as thick as my red line, I'm drawing red line and it's thicker so that everyone in the video or observing the video that they wouldn't have difficulty to see this line, but always use sharp pencils. First thing first, what you're gonna do is you're gonna draw two vertical dotted lines over here to make specified your drawing space. Have a good read at the question. Have a good read at the question. I'll give you the question. Read the question. Why are you expected to draw the graph? How much are they expecting out of you? In which location are they expecting you to draw?
Between the surface of the earth and the moon.
Between the surface of the earth and the moon, which means here to here, not over here, not over here. So we're gonna essentially keep our graph over here. So because they're asking only for the combined graph, so we might as well not bother to go through the trouble of drawing these two individual top and the bottom line. I mean, the individual gravitational field strength line for this one, individual gravitational field strength line for this one, we might as well draw the whole combined line. And combined line আঁকার জন্য আমাদের কয়েকটা point, to draw the combined line properly, we need to consider a couple of factors. First one is that at the surface of the earth, the gravitational field strength is supposed to be bigger compared to at the surface of the moon, because moon has a smaller mass. So moon is not going to have the same amount of surface area. It's a gravitational field strength compared to the earth. Earth will have a bigger value, and because it is a gravitational field strength composite graph, these two things will have to exist on opposite sides. So I might as well locate 2 points for my convenience of drawing. Let's say I'm going to give one of these green points over here. Let's say I'm going to start my graph from this point, and for moon I'm going to put it over here. You don't have to have a measurable value over here because this y-axis doesn't have any scale, but these two things have to be visibly smaller compared to each other, or bigger compared to each other. Earth value should be large, moon value should be small. The second thing you have to understand that because Earth has a much bigger mass, which means it has a much stronger force, the null point should be more close to the moon, because যত Earth থেকে দূরে যাব, the further we get closer to away from the Earth, the attraction of Earth is going to become weaker. Attraction of the moon is going to become stronger. Somewhere over here, not exactly at the halfway point, somewhere close to the moon side would have the equilibrium point, or the null point. So this position of the crossing of the curve should be located somewhere over here. I mean, not exactly, not very close to the moon, not very close to the halfway point. It should be on the right of the halfway point. So assume a position over here. So I'm going to be giving a dot over here. So these are 3 dots that we know, and we also know the shape, that this is going to be a negative exponential, cutting the x-axis at this point, and eventually it can become negative exponential over here. So let me try my magic with this curve thingy. Work with me. Arc2.
Sir, why is the shape like this? There was a
Because
reason, right?
because this is the vertical sum of these two numbers, this number and that number, this number and that number, this number and that number. You add these two numbers, you get the central line. বুঝা গেছে? এই shapingটা আঁকতে একটু কষ্ট হবে, because you have to draw a decreasing curve over here and then again another increasing curve over here, but practice makes every man perfect. Yes, Abiyaz, you have a question. You raise your hand. Bolo.
Sir, for a case where this graph would be labeled with actual numbers, would we start from the surface of the earth? Would we start from 9.81 and then from the surface of the moon, should we end at like 1/6 of 9.81?
Yes, absolutely.
And sir, would they ask us to calculate the position of the null point in respect to either body?
We'll see. Yes, there can be those calculations. There can be. I think a question এই আছে তো এই যে determine the distance in terms of RE from the
স্যার
center.
আমার এইটা নিয়ে প্রবলেম ছিল স্যার।
আচ্ছা হ্যাঁ, প্রবলেম যাদের আছে প্রবলেম বলবো, সমস্যা নাই, একটা করে কভার করছি। We have this problem over here. I'll help you solve this one, don't worry.
Okay, sir.
আচ্ছা, before I just move on, yeah, I'll take more questions. Fardin, yes. Abes, তোমার কোশ্চেন করা
Sir.
Do you have more questions?
No, sir, it's fine.
ঠিক আছে, ওকে। হ্যাঁ বলো, Fardin বলো।
স্যার আপনার বেসিক্যালি আমরা লাইক ওই যে মানে সাইন কনভেনশন দিয়েছি, তো আপনার লেফট সাইডে হচ্ছে পজিটিভ যদি গ্র্যাভিটেশনাল ফিল্ড স্ট্রেংথ মানে যদি আর্থ দিকে যাইতো অবজেক্টটা, রাইট? আর রাইট সাইডে নেগেটিভ, কারণ মুনের দিকে যাচ্ছে, তো তাই দেখে আপনার নেগেটিভ দিকে বাড়তেছে মুনের গ্র্যাভিটেশনাল ফিল্ড স্ট্রেংথ, তাই না? গ্র্যাভিটেশনাল ফিল্ড স্ট্রেংথ বুঝছি স্যার।
If you want, oh my bad. If you want, you could also draw this graph like this as well. তুমি যদি এরকম একটা তাও তোমাকে ফুল মার্কস দিত।
ও আচ্ছা, থ্যাংক ইউ স্যার।
This would pretty much mean the same thing, but you get full marks for this graph as well. The examiner is going to compare the magnitudes because question এর কথা বলে দেয় কোন ডিরেকশনে পজিটিভ, কোশ্চেনে বলা নাই, বলছে
না বলে নাই,
বলা নাই। So you have the opportunity to draw either of this graph. Pretty much they mean the same idea. Okay.
Achha,
so for those of you who have other parts, questions in the other parts, I'll entertain. So I'm going to start covering this question from the first point. So C1 will say there is explain why there is a point between the Earth and the Moon at which the gravitational field strength is 0. So you better get your grips on this one. Then it says determine the distance in terms of RE from the center of the Earth at which the gravitational field strength is 0. So এখান থেকে আমাদের গ্র্যাভিটেশন ফিল্ড স্ট্রেংথ কোথায় 0 হবে, এটা আমাদেরকে RE টার্মসে বাই করতে হবে। এই ক্যালকুলেশনটা কেমনে করবা সেটা আমি তোমাদেরকে দেখাই দিছি, ডোন্ট ওয়ারি, don't panic. Acha, before I would have to take help from this picture, so I might as well select and take it out. Allah, এখানে তো জায়গা নাই। আচ্ছা, সমস্যা নাই। Kids, have a look. I'm gonna do some drawing over here. I need you to keep your eyes peeled and your ears open. This word eyes peeled is so, I mean, if you think literally, I mean, doesn't that give you a chill? Like someone is peeling your eyes. First comes cornea, then aqueous humor, then they get to your lens and they're slowly going through the peeling process. And
I usually don't think about that stuff, so.
Sir, I do think about that, so I feel you.
Come to think of it, let me show you just one thing. A small distraction, or you can say break, because we are doing pretty heavy classes. That was
স্যার ওয়াই আই হঠাৎ করে এটা কি?
এই যে দূর ওপেন ইমেজ ইন নিউ ট্যাব, হ্যাঁ বেজাল নাই, এটা দেখো।
Change it. Can we please go back to physics?
Sure.
It's mildly horrifying.
Near horrifying. It's just how I feel all the time.
It's not essentially real, but come to think of it, I mean, you blink and then the eyelid just vanishes. Where does it go?
The eyelash.
Where?
Sir, it falls off.
The eyelid does not vanish. Oh my god.
Sir, it falls off. It's just really small.
Okay, let's consider this is the line joining the centers to center of the Earth and the Moon, and we're trying to find out where this location where we have the null point. So let's assume that this is our null point. So আমাদেরকে বাই করতে বলছে কার রেসপেক্টে বাই করতে বলছে সেটা একটা আমরা দেখি। আমার কোশ্চেনে বলছে হচ্ছে determine the distance in terms of RE from the center of Earth. So আমরা center of Earth থেকে বাই করতে যাচ্ছি, so we might as well consider this much as x, so that much should be what, total minus x. So this much should be 60 RE minus x. ঠিক না? So
Yes.
that is the key part. So we're going to use this information to calculate the forces over here. You have to understand that this is the location where the magnitude of the force should be equal. Force due to Earth should be equal to force due to Moon. So because we're trying to get the value, we're not going to place the minus sign over here. Or should I place the minus sign over here? Vector এর জন্য minus sign দিতে হয়, potential এর জন্য minus sign দিতে হয় না. So should I give a minus sign or should I not give a minus sign? I'm a bit
সাইন নিয়ে অনেক প্রবলেম হইছে ওয়ার্কশিটের, অনেক ম্যাথসে।
এই প্লাস মাইনাস নিয়ে?
হ্যাঁ স্যার।
আচ্ছা দাঁড়াও, আমি লজিক্যালি চিন্তা করে বলি, লেটস সি হাউ মাচ কারেন্ট ক্যান আই গেট। mass is equals to mass, এদিকে gmm কাটাকাটি যাবে, এদিকে হবে 4 - r হোল স্কয়ার। Is a minus b whole square is the same as b minus a whole square?
No.
Yeah. Can you repeat that?
Yes, it is.
It is.
A minus b whole square is equal to b minus a whole square.
It is.
Other than me speculating in my brain, why don't we just go ahead and try this out, and we'll find it the hard way. Don't worry. So I'm making a master code this. I'm going to give you a vertical line over here. So first I'm going to try it without the sign, and then I might as well try it with the sign and come to a logic of understanding that what should be done. So here I'm going to write that force from Earth equals to force from the Moon. So let's say the hypothetical object has a mass of small m, or you could directly start from g equals to g. G equals to g দিয়ে করি, force লেখার দরকার নাই। That location where the force should be 0, the gravitational field strength due to Earth should be equals to the gravitational field strength due to Moon. So আমি যদি এখানে ডিরেকশন লিখি, so g into mass of Earth, এখানে কি হলো, মুন এবং আর্থের ম্যাস কি কিছু নাম দিয়ে দিচ্ছে? না, ভ্যালু দিচ্ছে, divided by x squared should be equals to g into mass of Moon, m subscript m, divided by that thing 60 RE minus x whole square. So the g and g crosses out, and তুমি ভ্যালু গুলো বসাবা, আর্থের ম্যাস গুলো বসাবা, ম্যাস। সো এখানে তুমি সব নাম্বার গুলো আস্তে আস্তে বসাতে থাকো। সরি, এটা বড় একটা দাগ দিয়ে ভুল করে ফেলছি। আর্থের ম্যাস কত বলছিল? 6.0 × 10⁻²4 divided by,
একটু লেফট সাইডে শিফট করেন তো যাতে জিনিসটা দেখা যায়।
sorry,
You can use the little text thing if you want to write stuff.
ওটা দিয়ে পাওয়ার লেখা যায় না, বাজাল। 10⁻22 আছে না?
Select and list these parts over the fractions, can't you?
তখন আমাকে দুইটা টেক্সট বক্স লিখতে হবে।
এভাবে ভালো স্যার।
স্যার আপনি শিফট 6 দেন, তাহলে হবে।
স্যার ইজ ইট লাইক যে মানে আমরা দুইটা পয়েন্ট থেকে কম্পেয়ার করে হচ্ছে গ্র্যাভিটেশনাল ফোর্স ইকুয়েট করতেছি, ইজ ইট লাইক দ্যাট?
না, আমরা একটা পয়েন্টে দুইটা ম্যাসে গ্র্যাভিটেশনাল ফিল্ডকে কম্পেয়ার করতেছি, একটা স্পেসিফিক লোকেশনে, দুইটা ডিফারেন্ট অবজেক্ট থেকে। এই হচ্ছে তোমার ইকুয়েশন। এই ইকুয়েশনে অলটুগেদার ভ্যারিয়েবল আছে হচ্ছে x এবং re. So you are going to get rid of these parts. Go ahead and work with this equation and find out the value of x. I mean, you do some magic over here, your mathematical magic. You guys are all mathematical magicians, I believe in you. So you can find out this answer, x equals to re into something. So you get this thing, and then you write this thing over here. So you are asked to find out the value of the x, which is to in terms of re. দেখো এটা হয় কিনা।
Hi, sir. Hi.
Acha. Now, if you consider the scenario that if we do consider the minus sign over here, let's say আমি যদি এখানে minus sign দিই, এখানে minus sign দিলে যে জিনিসটা হবে, I'm just trying to figure out the consequences. এখানে যে minus sign দিলে জিনিসটা হবে, ultimately এগুলো সব ক্যালকুলেট যে কাটা যাবে। সো ultimately যেটা তুমি যখন এটাকে যখন ব্রেকডাউন করবা, আমি আচ্ছা আর টু স্পেস দিয়ে লিখি এখানে। আমাদের তো এই নিচে পার্টটুকু তো পারপাস শেষ হয়ে গেছে না, এটা তো লাগতেছে না আর। I'll delete this.
Sure.
So আমি যদি এখানে জাজ করি, let's say if we consider that minus sign, we might as well run into some trouble. সেটা হচ্ছে this equation ultimately look like this. that x square equals to some number which would be the division of these two numbers. সামনে একটা minus থাকবে, so let's say that number into 60 re minus x square. And এখান থেকে যে প্রবলেমটা হবে sorry minus x whole square, আমি এটা ভুল লিখছি, minus x 60 re minus x whole square, এখানে হ্যাঁ এখানে ঠিক লিখছি। সো এখানে যে প্রবলেমটা হবে সেটা হচ্ছে once you do this multiplication তোমার এদিকে একটা স্কয়ার আসবে, আলটিমেটলি ওইদিকেও একটা মাইনাস স্কয়ার থাকবে। সো তুমি সাইড চেঞ্জ করার পর তোমার স্কয়ার দিতে কাটাকাটি যাবে না, দিস উইল once again become a quadratic equation. So that's not supposed to happen. That's not supposed to happen. So তোমার সো আইডিয়াটা হচ্ছে যে এই নাল পয়েন্টের মেথড বের করতে গেলে আমরা মাইনাসটা বসাতে পারবো না। If you want to give the physics behind it, you must always say that in terms of physics these two forces will cancel each other out. So Fg hold up, why am I messing this up? Yeah, I'm actually messing this up. শুনো আরে আমি তো একটা স্টুপিড, আমি অ্যাকচুয়ালি স্টুপিড। এই পয়েন্টের রেজাল্টেন্ট ফোর্স 0 তাই না?
Yes sir.
Yes.
এই পয়েন্টের জন্য force from earth plus force from the moon equals to 0.
Oh হ্যাঁ
ঠিক আছে, এখন তুমি now whenever you are going to try to put these numbers, one of these force has to be positive in its vector sign and the other force itself has to be negative in its vector sign. If you do the side change, automatically you get positive numbers. I was thinking the wrong way.
Yes sir.
It is very simple. Inherently I was missing up some information in my head, so didn't see the bigger picture. Now this is the bigger picture. Abhias bolo, you raised your hand.
So I can understand the formula that you set down for this question.
Which part?
In the beginning where you wrote, can you scroll to the left a bit, sir?
Yeah, I'm here that the gravitational field strength due to Earth in the null point equals to gravitational field strength of that position due to the moon. The two gravitational field strength would be equal, which basically means that the gravitational field strength is 0, or that is what how you define the null point. One of the logics can be the forces are equal, or you can say gravitational field strength are equal. That is equally works. Bolo.
I understood that part, sir, but what you wrote underneath, like gravitational constant into ME,
mass of Earth,
and then is equal to
subscript T, that is equals to gravitational field strength into mass of the moon.
Mass of the moon. I thought it was too big.
No. My bad. My handwriting. I meant it as a subscript.
Sir.
Understand. Thank you.
Sure. বলো।
এখানে তো ডিসটেন্স আছে, আমার তো তাহলে নেগেটিভ ভ্যালু আসার কথা না মতো।
হ্যাঁ নেগেটিভ ভ্যালু আসার কথা না, কারণ কিন্তু that's what I said, that we are not supposed to have a negative value, but if you get a quadratic equation solve করার পর তো প্লাস মাইনাস ভ্যালু দুটোই আসতে পারে। তুমি মিডল টার্ম করো বা হচ্ছে তোমার minus b plus minus root over b square minus 4ac করো, whatever you do. So that's why it's not supposed to happen. So logic tells us that the distance can never be negative. And then it popped in my head that it is not supposed to be negative because inherently this negative sign is taken care of.
আচ্ছা বুঝছি।
বুঝেছে?
Sir, আমি নেগেটিভ সাইডে একটু বুঝি না স্যার। নেগেটিভ
সাইড আইডিয়াটা হচ্ছে the whole point of the null point is that the resultant force over here should be 0, which means the total force available from all the sources available would have a vector sum of 0. So I can write force from Earth plus force from moon equals to 0. But whenever you're going to put those two forces as vector quantities, how would their values should be included in the equation? Should they all have the same sign? No, because force of Earth from this point is going to work towards left, force of moon is going to work to the right. So whenever you replace these symbols for the individual values, if this force is placed as a positive number, this force have to be placed as a negative number because of the direction implication. As a result, whenever you do the side change, your minus sign automatically vanishes, and then you go ahead with the math.
আচ্ছা হ্যাঁ পজিটিভ হয়ে যায়। বুঝছি।
Yes sir.
Yeah.
Beautiful. Any other part of problem from this question? Anyone? Eta parso? It is the basic idea, theoretical question. So these are the questions that Arnav Osha asked me over here, and I told you earlier that I'm gonna move back to my key list. আচ্ছা, would it be better if I just go question by question and ask you that এটাতে কেউ কোথাও আটকাইছো কিনা কোথাও আটকাইছো কিনা other than going through individual lists?
Yes, sir. I think that would be way better.
I think yes.
প্রমাণ পিরামিডি করো। I mean, write yes or no. I mean, if you think this idea. I mean, what I'm proposing that I start from the very beginning of the worksheet, go one question by one question. That do you have any problems in this one? You respond. If you don't respond, I move on, and I don't ever come back to the earlier question. I'm just kidding. So I think that would be a more organized version, because we have so many people popping up with so many different lists of trouble, which I really appreciate. But you have, I mean, you have a lot of common, then you don't have a lot of common. Okay, I'll start from number 1 anyway. Number 1 এ কার কোনো প্রবলেম আছে? নাই। নাম্বার 2 তে কার কোনো প্রবলেম আছে?
স্যার আমার আছে 2C তে।
2C দেখবো, শিওর।
স্যার 2C অ্যানসার মিলাইতে পারছি, কিন্তু আমার এখানে অ্যানসার আসছে নেগেটিভে, মানে -4.19 * 10⁻⁷, কিন্তু মার্কস স্কিমে ওরা বলছে ইগনোর দ্য সাইন। আর এখানে হচ্ছে গিয়ে ওরা গ্র্যাভিটেশনাল পটেনশিয়াল এনার্জির যে মানে ডেল ফাই, সেটা আমি ইউজ করছি -gm/r। কিন্তু আবার নাম্বার 15 এ ওরা এই টাইপেরই একটা ম্যাথ করছে, কোয়েশ্চেন নাম্বার 15 এ ওরা আবার ফর্মুলা লিখছে gm/r শুধু, মানে মাইনাস দেয় নাই, মানে এই টাইপের কোয়েশ্চেনে সাইনের প্রবলেম হচ্ছে।
আচ্ছা, I'll help you to understand this problem of the sign. Let me show you. একটা জিনিস হচ্ছে গ্র্যাভিটেশনাল পটেনশিয়ালের বেসিক এক্সপ্রেশনটা হচ্ছে phi = -gm/r। তোমরা সারা জীবন সব সময় এই ফর্ম এই এক্সপ্রেশন দিয়ে লিখবা, এই এক্সপ্রেশন দিয়ে এই কাজ করবা। Now in the cases where the mark scheme messes with your head, it apparently looks like, the reason is that the mark scheme is somewhat concised and aimed for the examiners. So in times, this is what they do. মনে করো, let's say one object has moved from this point to this point within a gravitational field, point 1 to point 2. So এখানে একটা gravitational field আছে, point 1 থেকে point 2 তে গেছে। So আমরা, if we are trying to calculate the delta GP, ঠিক আছে, we might write what m into del phi. So this might as well be written as m into -gm/r1 minus gm/r2. ঠিক না? This is the expression that you are supposed to work with. Ultimately, তুমি যদি এটাকে পুরোপুরি গুছায় ফেলো, you're gonna get this thing gmm, কে আমি m টাকে বাইরে নিয়ে আসলাম, g টাকে বাইরে নিয়ে আসলাম, multiplied by 1/r2 plus -1/r1. এটা হয় না? দেখো, it is possible that in the mark schemes they might as well not give you this whole thing. এটুক না দেখায় পুরোপুরি ডেল্টা জিপি = এক্সপ্রেশন লিখে তার সরাসরি আনসারটা দিয়ে দিবে। সো ডোন্ট কনফিউজ যে তারা r2 থেকে r1 সাবট্রাক্ট করতেছে কেন, r1 থেকে তো r2 সাবট্রাক্ট করার কথা, ওই মাইনাস সাইনটাকে হিসাব করেই তারা এই কাবজাবটা করছে। That is one of the problems that you might have had. The second problem that you just asked, that has a simple solution. Same problemটা explanation হচ্ছে এরকম. Let's say you have an object over here which reached at this point of gravitational field. Let's say that point is, let's say 1, from an infinite distance. So it traveled from position 2, which is infinite, to up to point 1. And infinite point the potential value হচ্ছে কত? Default potential value হচ্ছে 0 by definition. So if you want to find out the delta GP for this case, how much is the delta GP over here? That would be m into delta phi. So that would be m into 0 minus gm/r1. এই r1 টা কোথায়? r1 টা হচ্ছে তোমার এখানে যে প্ল্যানেট থাকবে সেই প্ল্যানেট থেকে এই পজিশনের ডিসটেন্সটা হচ্ছে r1. And the object that you are moving, the object that you are trying to move from infinite distance to this point, that object's mass হচ্ছে small m. So ultimately এখান থেকে তুমি যদি হিসাব করো, মাইনাসে বাদ গিয়ে তোমার কি থাকবে? পজিটিভ হয়ে গেল না?
Yes.
So ওরা তোমাদেরকে হয়তো কোশ্চেনে, in the question they might not as well bother to show you this whole working. They might directly give you this expression and you might feel a little bit boggled. But these are the two most common cases that happen in the mark scheme, where the students feel confused about the signs.
Sure.
Does it make sense?
হ্যাঁ স্যার, কিন্তু তাহলে নেগেটিভ সাইন কি দিব? মানে আমার অ্যানসারে নেগেটিভ সাইন আসছে।
বলি নেগেটিভ সাইন আনসার করার সবচেয়ে কনভিনিয়েন্ট এবং ডিপেন্ডেবল এবং মানে গুড ওয়ে হচ্ছে, you will do your math as you have learned your theory and you will place your science as you have learned in your theory. whenever you writing this answer, মনে করো হচ্ছে তোমার কোনটা, এটা তো সমস্যা না, এটা তো সমস্যা, এটা সমস্যা, তাই না?
হ্যাঁ স্যার C1 হ্যাঁ
হ্যাঁ, তুমি আনসারটা লিখবা হচ্ছে এইভাবে, let me just show you in my painted, সেটা হচ্ছে এইভাবে লিখবা। মনে করো এটা হচ্ছে তোমার আনসার লেখার জায়গা, ঠিক আছে? কিছু বুঝলা?
হ্যাঁ স্যার সাইনটা ব্র্যাকেটে দিব।
হ্যাঁ, সাইনের ব্র্যাকেটে দেওয়ার সুবিধাটা হচ্ছে, the benefit of putting the minus sign in this fashion is that if the examiner is looking for a minus sign, it is there. If the examiner is not looking for a minus sign, it is within brackets, so they can choose to disregard it. This is the safest way of putting the minus sign in your answers.
আচ্ছা স্যার, আর অ্যাকচুয়াল ওয়ার্কআউট যেটা ওটাতে মাইনাস থাকবে, জাস্ট অ্যানসারে হচ্ছে যে আমরা এটাকে ব্র্যাকেটে দিয়ে দিব।
Yes, exactly, that's what I meant.
আচ্ছা স্যার, থ্যাংক ইউ।
Sure, no problem. Acha, that was for number 2. Number 3 থেকে আর কোনো problem? Anyone? Number 3, the binary star system.
স্যার আমার নাম্বার 2 এর C1 নিয়ে একটা কোশ্চেন ছিল।
Number 2 এর C1 বলো।
হ্যাঁ, এখানে তো মানে আপনি যে পেইন্টে যে সিনারিওটা দেখালেন যে ইনফিনিটি থেকে একটা পার্টিকুলার পয়েন্টে আসছে, সে পার্টিকুলার পয়েন্টে আসলে তো ইউজুয়ালি পটেনশিয়াল তো কমে যাওয়ার কথা না?
হ্যাঁ, 0 থেকে কমে যাচ্ছে।
ও বুঝছি।
ওকে, নাম্বার 3 নিয়ে কারো কোশ্চেন আছে? নাই। Number 4, Purban, see your own list and talk to me. Do you have anything to ask for number 4? Because I cannot essentially go through all the lists individually. That's why I'm going through sort of like a bidding process. Calling out. Number 4, anyone? No. Number 5?
স্যার আমার জাস্ট একটা টার্মে প্রবলেম ছিল যে লিনিয়ার স্পিড বলতে আমরা কি বুঝি সেটাই।
Instantaneous speed at that instant.
স্যার এটা কি নরমাল স্পিড, মানে অ্যাঙ্গুলার তো না?
না,
tangential to the motion.
লিনিয়ার স্পিড হচ্ছে মিটার পার সেকেন্ড আর অ্যাঙ্গুলার স্পিড হচ্ছে রেডিয়ান পার সেকেন্ড। এখন তুমি নিজে বুঝো।
স্যার বুঝছি।
ইউনিট দুটো বললাম so that you can make a better comprehension.
হ্যাঁ স্যার বুঝতে পারছি, মানে ইনস্ট্যান্টেনিয়াস যে স্পিডটা আছে আর কি।
হ্যাঁ, ডিসটেন্স ওভার টাইম।
আচ্ছা স্যার, থ্যাংক ইউ।
Sure. 5 এর কোনো প্রবলেম? 6 এর কোনো প্রবলেম? বললাম তোমাদের 5 এর তো তোমাদের নাম্বার সি নিয়ে কোশ্চেন থাকা উচিত। তোমার নাম্বার 5 এর সি নিয়ে কেউ আটকাও নাই? লাইক নো ওয়ান?
আগে সলভ করা হয়েছে।
ও, এটা আগে সলভ করছিলাম লেকচারের মাঝখানে?
হ্যাঁ স্যার।
Oh, I am so cool. Number 6 এ কারো প্রবলেম? 7? আচ্ছা, 7 সলভ করা হয়েছে, ওই যে the whole thing, yeah, we took some good amount of time for 7. 8? 9?
9B2.
9B2 দেখবো। A stone of weight 3.0 Newton is fixed using glue to one end P of a rigid rod CP as shown in figure 1.1. The rod is rotated about end C so that the stone moves in a vertical circle of radius 85 centimeter. Okay, vertical circle. Beautiful question. The angular speed omega of the rod and the stone gradually increases from 0 until the glue snaps. The glue fixing the stone snaps when the tension in it is 18 Newton. For the position of the stone at which শেষ করি, question নিব, হাত উঠে রাখো। For the position of the stone at which the glue snaps, on the dotted line of the circle mark with the letter S, the position of the stone, calculate the angular speed omega of the stone. Now, I told you earlier that for the vertical circle, in which case do you have the maximum stress build up within the string? That was at the lowest point, because at that point, your centripetal force was working upwards, your weight was working downwards, so the tension has to overcome the weight to provide the necessary centripetal force. So the biggest tension or biggest amount of tension build up within your string, the example that we discussed in the theory part, was at the lowest position. So for this case, that location should be oh no. Yes. That location should be located here. You write an S over here, you score that mark. And then it says number 2, calculate the angular speed omega of the stone for whenever the stone snaps. The question says that tension value was 18 Newton. The glue fixing the stone snaps when the tension in it is 18 Newton. Now here's the deal. What is the weight of the stone?
3 Newton.
3 Newton. So let's consider this figure and try to work with this one piece by piece. So let's say I'm going to try and draw a rectangle over here. Let's use green. Okay. And let's say another glued object over here. No. You don't have to do this green drawing. I'm just drawing this over here to make sense with you. Now, try to understand. To have the circular motion happening at the lowest position, the centripetal force should work upwards. So let's say this is the centripetal force. And the weight is definitely by default, the weight is a force that will always work downwards. So let's say this is the weight. Okay. Now the centripetal force should be provided from the tension of the glue sticking. So that way your centripetal force should be somewhat, if I write this thing, let's say I'm tension take aaki. I don't want to cover up this red arrow. That's why I'm drawing the tension with my bare hand. Let's see with a different color, let's say orange. So the tension of the string at this position should work like this. So this is the tension, this is the weight, this is the FC. And because this is a circular motion object, we can also write that the resultant force is the centripetal force, which has to come as a subtraction of tension minus weight. Put your head into this equation, come to a conclusion that whether this makes sense. If you have question, ask me about this equation. Is this equation okay with you?
Yes.
So now you start putting down values. So FC hoche m omega square r.
Sir.
Tension hoche 18. Weight hoche 3. M টাকে তুমি পরে বসাবা হচ্ছে w by g দিয়ে। ওখান থেকে তোমার weight m টা চলে আসবে। Radius হচ্ছে তোমার automatically আমাদের রডের length যেটা কোশ্চেনে দেওয়া আছে। So everything else works out and you can get the number. বলো।
টেনশন কেন বলতেছি? এটা তো স্ট্রিং না, এটা তো রড না।
Acha, that question that you asked me, yes, I remember. Yeah. The reason we are calling this to be a tension is that through solid objects, you can also have tension force build up if you are trying to pull it apart. It's not essential that an object would have tension for experience tension. It has to be a string or a rope or a flexible material. It doesn't have to be. Think about a solid piece of rod. If you pull it on opposite directions, there will be force of tension build up within itself. If you push it from opposite direction, there will be force of compression build up in this within this rod. Flexible stuffs like strings or ropes, they cannot experience compression. They will become slack when they don't have tension. But solid objects can experience tension and compression both. So because this stone, because of its inertial behavior, this stone is trying to get out of the circle. What do I mean by this? That like Newton's first law, that every object would prefer to maintain their velocity. To make the change of its velocity direction every once in a while, for every instance, due to the circular motion, we are continuously pulling that stone towards the center. That pulling is done by the glue and with that material. If you just try to visualize, if this glue did not snap, for example, let's say it was going round and round in a circle, let's say at some point this pivot point becomes detached, then the entire thing would go out, right? Out of the circle, in a tangential direction, of course, so it's going to go out in a tangential direction. So if that is the scenario, it means what? That this mass system, as it was rotating, was always trying to get out of the circle. So that is producing the tension within the connecting mechanism, which in this case is the rod. It doesn't exclusively have to be a rope or string. It can also be a solid object. No big deal. বুঝতে পারছি? Okay, beautiful. কেউ একজন মাঝখানে একটা কোশ্চেন করতেছিলা? I asked you to raise hand and then you didn't raise hand. Then you are not asking this question anymore. Okay, beautiful. Moving on. Number 10. Number 10 graph. বলো.
Sir, 10b2.
10b2 দেখবো question দেখে আসি the earth may be considered to be an isolated sphere of radius r with its mass concentrated at its center. The variation of the gravitational potential phi with distance x from the center of the earth is shown in figure 1.1. Beautiful, no problem. একটু ওয়েট করো হ্যাঁ 2 মিনিট সময় আছে 1 মিনিট সময় দাও আমাকে আমি একটু আসছি Sorry, I'm back. Hasta la vista. Baby. What the hell? Never mind. আচ্ছা কি বলতেছিলাম কোশ্চেন পড়তেছিলাম The earth may be considered to be an isolated sphere of radius r with its mass concentrated at its center. The variation of gravitational potential phi with distance x from the center of the earth is shown in figure 1.1. Acha. The radius of the earth is this much. By considering the gravitational potential of the earth's surface, given a value by the mass of the earth. Acha. To say a meteorite at its infinity, meteorite has infinity to the earth, the speed of the meteorite when it is distance toward the earth's surface is working. তোমাকে এটাতে প্রবলেম?
Yes, sir.
Okay, we'll pick this up. হ্যাঁ এটা তো সব পিস বাই পিস আচ্ছা আমার শুধু গ্রাফটা হলেই হবে আমি শুধু গ্রাফটা নিয়ে যাই Okay, so the meteorite is coming from infinite distance reaching to a distance of 2r over here and তুমি এই গ্রাফ থেকে read off করো try to take the value that at 2r distance from the center of the earth what is the value of potential. The potential is somewhat above this fourth line. This is 4, so this is supposed to be 0 -1 -2 -3. This is supposed to be -3.2, so I can say this is -3.15. বুঝতেছো এই পয়েন্টটা কিভাবে বাই করতে বুঝতেছো?
হ্যাঁ স্যার বাট আগের 8টা প্লাস করব না মানে 3r হবে না মানে সেন্টার থেকে 8টা এটা কি নিব?
ওরা কি সারফেস থেকে 2r বলছে? আমি তো কোশ্চেন ভাবে খেয়াল করলাম না। হ্যাঁ তাহলে 3r নিতে হবে। সরি আই এম সরি I was mistaken. I made a bad mistake of not reading the question carefully. When it is a distance of 2r above Earth's surface, তার মানে হচ্ছে সেন্টার থেকে হবে 3r. We have to look for the 3r point. Yes, thank you. I was wrong. So we have to go for the 3r point. 3r হচ্ছে কোথায়? 3r হচ্ছে এখানে. So this is the point. এই পয়েন্টে কোঅর্ডিনেট বাই করো। এই পয়েন্টে কোঅর্ডিনেট হচ্ছে each division over here is 0.2. So this should be -2.1.
Yes, sir.
ঠিক আছে, this is -2.1. So infinite distance থাকলে হচ্ছে 0, এখানে হচ্ছে -2.1. So which works for us. So তার মানে হচ্ছে আমাদের আমাদের কি কাইনেটিক এনার্জি বের করতে বলছে, স্পিড বের করতে বলছে না কাইনেটিক এনার্জি বের করতে বলছে, কি করতে বলছে?
স্যার স্পিড
বের করতে বলছে। ওকে হ্যাঁ স্পিড বাই করব, ডোন্ট ওয়ারি। So k equals to হবে হচ্ছে delta gp. So if I go ahead and write this down, half mv square.
স্যার এখানে আমার একটা কোশ্চেন ছিল যে আমাদের যে স্পিড অফ স্যাটেলাইটের যে ইকুয়েশনটা যে v √gm/r ওটা কেন এখানে ব্যবহার করতে পারছি না?
Because according to this question the meteorite is not coming around to go around the earth in a circular orbit. According to the question the meteorite was located at infinite distance, travel straight to the earth to a distance. This is not the case. This is the case. কত ছিল জানো? 2 কত দেখলাম? 2.1 হ্যাঁ 2.1 into 10 to the power 7. 10 to the power 7. এটা তো এখানে তোমার m আর m কাটাকাটি চলে যাবে, so this m and m the mass of the meteor cancels out on both sides. You just do the mathematics and you get the value of p.
Okay sir, thank you.
No problem. এরপর আছে হচ্ছে 3 নাম্বার 3 তে কার কোনো কোশ্চেন আছে? নাম্বার 3 was pretty simple I believe, because the moon exists, that there will be additional forces. I think we discussed number 3.
Sir, you did.
Yes, I think I did. 11 is all definitions. You can skip number B if it doesn't make sense to you. We'll do the electric field chapter, then you can essentially very easily do number B.
11 sir, 11A2.
Yes sir, 11A2.
Newton's law of gravitation applies to point masses. State Newton's law of gravitation. আচ্ছা লিখলা। To the বলছে explain why although the planets and the sun are not point masses, the law also applies to planets orbiting the sun. আচ্ছা এটা কনসিডার করার দুটা মানে প্রাইমারি রিজন হচ্ছে the distance between the planets and the sun is too large compared to the radius of the planets and the sun. So because of that comparison, the radius of the sun or the planet in comparison with the distance, how far apart those things are, that can be considered to be negligible or too small. মানে হচ্ছে তুমি যদি appropriate scale দিয়ে আঁকো, within a scale if you try to accommodate let's say sun and Jupiter, if you draw with the appropriate scale, both sun and Jupiter would appear to be really small objects, not essentially point masses, but they would appear to be really small objects. That's why we can consider them to be working as point masses and directly go ahead and apply Newton's law of gravitation for those cases as well. It's about the idea of negligibility in terms of while comparing a very large value with a very small value. এটা একটা আইডিয়া,
তার মানে
এক মিনিট, এটা একটা আইডিয়া হতে পারে। আরেকটা আইডিয়া হতে পারে, চুপ কর, সরি, এটা একটা আইডিয়া হতে পারে। আরেকটা আইডিয়া হতে পারে যে we can consider a spherical object to have all of its mass concentrated at the center, because both of these things with equal masses would produce identical shape for the gravitational field. So if you consider the distance between from center to center, the size of the object really doesn't matter. This can be a second explanation. If you consider the entire spherical objects to be a single particle which is located at its COG point, then you can effectively apply the idea a law of Newton's law of gravitation, which is from point to point mass. So there are two different aspects. একটা হচ্ছে ডিসটেন্স কম্পারিজন করে রেডিয়াস গুলোকে নেগলিজিবল ডিফাইন করা, অথবা তুমি পুরো স্ফেরিক্যাল ম্যাচটাকে সেন্টারে কনসেন্ট্রেটেড জাজ করে ওটাকে একটা সিঙ্গেল পার্টিকেল হিসেবে জাজ করে তুমি ম্যাচ করতেছো, সেটা হইতে পারে। Just to be on the safe side, we'll have a look at the Mars scheme and then I'm going to take your questions. 11, have a look. 11 এর Mars scheme কি বলছে? Gravitational separation mass greater than radius. Acha, they say that's first one that I go in for. Much greater. Mass is underlined. Okay. Examiner's report. Candidates should realize that Newton's law of gravitation applies because the diameters of a planet and the sun are very much less than the distance between them. Okay, so they haven't entertained the second point, but that can also be a logical point in applicable cases. But in this case, they only go in for the first explanation. Bolo, question bolo.
স্যার যদি এরকম হয় যে আমি সেকেন্ড পয়েন্টটা দিছি আপনার, আমি ফার্স্ট পয়েন্টটা দেইনি, তাহলে কি আমার মার্ক দিবে না? আমার সেকেন্ড পয়েন্টটা তাহলে ঠিক আছে আপনি যদি বলছেন, কিন্তু মার্ক
নাও দিতে পারে।
আচ্ছা,
নাও দিতে পারে এই জন্য বিকজ আমি বলি কেন, এক্সামিনার্স আর instructed to give the students mark based upon the mark schemes. Mark scheme is the sort of like the Bible for taking copies. Okay, so what I mean by this is that if something is not present in the mark scheme, the examiners can cut off all the marks even if that is correct. Well, there is a different factor. That is, let's say a student wrote an answer which is not at all included in the mark scheme, but that is logically correct and the student deserves a mark. The teacher feels like this. The teacher can give the kid that mark but they are gonna have to write an additional instruction to the CA people that this part of the K mark was given. So that's what this is something that I came across to know from one of the websites when I actually did some research on the website quite some earlier days in one of the websites, but not in the CA website. So I cannot validate this information, but that's what I came across from someone's comment. I believe that person was one of the registered teacher. So my point being is that if the examiner wants to give you the mark for a correct answer which is not present on the mark scheme, they would have to write an additional letter aiming at the principal examiner that this answer is also correct, so I gave mark to this kid or something like that, which in my opinion the trouble many teacher or many examiner might not put up with. Do I make sense?
Acha.
I mean, they should, but they can choose not to.
Oh, okay.
Exactly. So I mean, if you Sajid, tomar je question, don't be depressed by me saying this. What I really want you to grasp is that that you have to practice more and more to get a good handle of the most common type of answer for a certain question. For example, ekhane ei question ta kore ora mark this 1. So for 1 mark question, they are highlighting this idea about distance and the diameter comparison. If this same question had a 2 mark in some other year question, then you might require the second one. So you would understand the relative weight of these two information to the examiner. For a 1 mark question, this is important. For 2 mark question, both of them are important. So you have to build up that knowledge base within yourself through practicing and observation. I cannot tell you all of this stuff, and I would not tell you all of this stuff, because in that case I would rob you of the enjoyment of finding these secrets. Let's put it that way.
Sir, what is the second point again?
Spherical masses can be considered to be single particle concentrated at their center, because the gravitational field that a spherical mass produce is identical as a particle of the same mass located at its center.
Oh yeah.
So that is the logic. Thank you very much.
Sir, মানে second logic হচ্ছে যে CG যেহেতু সেন্টারে they act as মানে they produce similar fields like particles.
Yes, the shape of the field is exactly same.
আচ্ছা স্যার। স্যার বাকি কোশ্চেন গুলো কালকে করি না মানে।
আচ্ছা ঠিক আছে, হ্যাঁ, yeah, we are past our time. কালকে ক্লাস কয়টায়?
Same time, sir.
Same time না? আচ্ছা ঠিক আছে। Kids, thank you for your additional 11 minutes of attention. We'll pick it up from this point, tomorrow's class. So we'll start from 12 and go on forward. Thank you. Good night. Allah Hafiz. I'll stop the recording, but I'm still online, so I'll take questions from you.
Thank you, sir.
Salam, sir.
Salam.